Alright, so find the value of a limit. So let's look at this image here provided. I might have opened this twice. Let's try it again. Okay, save. Just give me a second here. I just gotta fix something quickly. Okay, so we're asked here to find the value of the limit of the following. So sine 2x, cos 3x, tan 4x, and so on as shown in the question. And we have to figure out which answer is correct, A, B, C, D, or E. So we'll start off by writing down the question. So we're trying to evaluate for the limit of x as it goes to 0, sine 2x cos 3x tan 4x over cos 2x sine 3x and tan 5x. So let me just move that so it's visible. Okay. So let's just double check that. Okay, so we have the same limit that we have to evaluate. So let's say we just substitute in 0 for everything and we just evaluate it the normal way. We would get the following. So, excuse me. So we would get, if we had sine 0 is just equal to 0. And then cos 3x, so cos 0 would equal to 1. So we have 0 times 1. Tan 0 would just be 0. And then we have cos 0 would be 1, sine 0 would be 0, tan 0 would be 0. So we get 0 over 0, which is undefined. So here we would be incorrect to say it's undefined. We have to follow a different process to find the limit. So here we would use L'Hopital's rule. So let me just give a quick definition of what L'Hopital's rule is. So usually when you see a situation where you have 0 over 0, you would use the following property of a limit. So the limit of x as it goes to z of some function f over some function g is equivalent to the limit of x as it tends to some constant c of the derivative of the top function over the derivative of the bottom function. So here that's what we're going to do. We're going to take the derivative of the top and bottom. So let's clear some of the board here. Okay, so give me a second. Alright, so the first thing we do here is we split up the function into separate components. So we'd say the limit, we'll take the cos and we'll keep them together. So cos 3x, so x goes to 0, cos 3x over cos 2x, because we know we can evaluate for this, times the limit x goes to 0 of sine 2x over tan 5x times the limit of x goes to 0, and we have the final one here. So we have tan 4x over sine 3x. So we can see how these two are equivalent. We just kind of split up the limit into 3 separate limits. And now we're going to use L'Hopital's rule. So for the first limit, we don't really need L'Hopital's rule. It's just 1 over 1, because cos 0 is just 1, so it'll just give us 1 over 1. And then the second one will have the limit of x to 0. So the derivative of sine 2x will be 2 cos 2x. The derivative of tan 5x is 5 secant squared 5x. So we know that the derivative of tan x is secant squared x. So here we're just going a little further. We do the derivative of tan, and then we do the derivative of the inside component, which is 5x, which is just 5, and that's how we get the 5 in the front. And then finally, we do L'Hopital's rule again. So we have the limit as x goes to 0. We get this top is 4 secant squared 4x over the derivative of sine 3x, which is just 3 cos 3x. So now when we evaluate, so this is the first component is just 1, and then the second component, 2 times cos 0, which is just 1, over 5 times secant squared secant squared 0. So we know that secant is just the inverse or the reciprocal of cos. So this will also give us 1. And then this limit will give us 4 times secant squared 0, which will be equal to 1, because we know secant is just the reciprocal of cos, and they both give us a 1 when we evaluate at x equals 0. And then finally we get 3, and then cos 0 is just 1. So we're left with 2, so all the 1's go away, and we have 2 times 4 on top, which gives us 8, and 5 times 3 on the bottom, which gives us 15. And that's our final answer. So that's our final answer. Right here. Okay, so looking at the solution. So they identify that you have to use L'Hopital's rule. Let's look at the options. So here B is the correct answer because we got 8 over 15. So here they select the correct answer. They don't show their work, however. So correct answer selected. Did not show the steps. Solution. So the solution is incomplete.